Hey guys, how you doing? I apologize for this light, but it's dark, and if I didn't have it on, it would be ugly. But anyway, Red Devil Chemist. Let's go ahead and work our last problem of the evening. This is 6B, gas loss 2. Very interesting problem. All right, let's read what it says. If 5 grams of nitrogen gas and 5 grams of chlorine gas are injected into a 2-liter vessel at a temperature of 65 degrees C, what will the partial pressure of each gas be? Then, what will be the total pressure of the gas in the container? So, let's also look at number 2, right? Three related. Which gas law allows the simple calculation of the total pressure in question 1? Let's go ahead and answer that one first. It's Dalton's law. And Dalton discovered that if you take the pressures of each individual gas and you add them up, then that will be the pressure of the total system. So on this system, I'm going to have the pressure of nitrogen, N2, plus the pressure of the chlorine gas, PCl2. That's what we'll call it. All right. So we're going to go up here and we're going to calculate the pressure of the nitrogen gas. All right, and let's see what we've got here. I've got 5 grams of nitrogen gas, okay? And I don't need grams, right? I need moles. So if I have 5 grams of nitrogen, okay? 5 grams of nitrogen. If I want to get moles, 1 mole of nitrogen gas, N2, will have the atomic mass, or the molecular mass, of 28.014 grams of nitrogen. All right, and if I do the math behind that, okay, if I do the math, let me get my calculator out, that's going to equal 5 divided by 28.014. That's going to be 1.78 times 10 to the minus first, or 0.0178 moles of nitrogen. Right. So we'll go ahead and do the other one too. Again, I need moles of chlorine. I need moles of chlorine. All right. So we have 5 grams of chlorine, Cl2. So 1 mole, and we'll put that in the numerator, of Cl2 is equivalent, let's see, 35.45 times 2. 35.45 times 2 is 70.9 grams of Cl2. So if I take 5 divided by 70.9, I'm going to get 0.00705 moles of Cl2. Yes, sometimes I have to write like that. So now we've got moles of both. All right. And let me pick that up. Drop my pen. It's been that type of day, guys. So I've got moles of both nitrogen and chlorine. I've got my volume. All right. So NCl2, or excuse me, N2 is 0.0178 moles. Volume is 2 liters. All right. And the temperature is 65 degrees C, and it says degrees C, so I know I'm going to have to add 273 to that. And that's going to be 65 plus 273, 338 Kelvin. Okay. Now let's look at our chlorine. All right, so moles of chlorine is 0.00705. Volume again is 2.0 liters. All right, temperature is going to be the same, 338 Kelvin. R is the universal gas constant. We'll go ahead and use the one we know, 0.0821. And that is atmospheres, liters, moles, K. All right. So now we've got enough information that we can put it into our ideal gas law, which was P. And I'm going to go ahead and just, I think we understand that. Divide that through by V, and that's going to give us pressure. And we'll call that pressure of the N2. Okay. And then pressure of the Cl2 is going to be nRT over V. Okay. So pressure of the chlorine is going to equal 0.00705 times 0.0821 times the temperature over 2. So pressure of chlorine is going to be 0.0705 times 0.0821 times 338 divided by 2. Or I got the pressure of the chlorine gas is 0.00978 atmospheres. Move that down a little bit. That's what I got. See how I did that? Now let's do the nitrogen. The pressure of the nitrogen is 0.0178 moles times the gas constant 0.0821 times the temperature 338 K over 2. 0.0178 times 0.0821 338 divided by 2. And the pressure I got, all right, is, let's see, 0, let's say plus, is the pressure of the nitrogen, is 0.0247. Does that make sense? Let's see. 5 grams divided by, wait, clear. Oh, that's 0.178. 0.178, and let's see the other one. That didn't really make sense, so I'm going back. Wait, 0. I did not do that, so that's going to be off a little bit. Do that one, and do that one. So that's wrong. Get rid of that. Okay, so I was wrong. All right, and when I started adding things up, it did not make sense. And that's why I'm always telling you guys, see if it makes sense, because that was a really small pressure. All right, so 0 point, that's not right. That's right. And that's right. All right. Make sure things make sense. Times 338 divided by 2. Whoop, that wasn't right. 0.178 times 0.0821 times 338 divided by 2. Now that one makes sense. All right, here I got 2.547 atmospheres for the PnO2. So I'm going to take it down here. P total equal 2.47 atmospheres plus the pressure of the chlorine gas, 0.0705, makes sense, 0.0821 times 338 divided by 2. Now that time I got 0.978, 0.978, so I'm going to write it down here, 0.978 atmospheres. Okay, so let's add that to 2.47. So my total, P total, is going to be 3.45 atmospheres. Our 3.5 atmospheres would be good because they only gave me two significant figures. So 3.5 atmospheres is what I'm going to report. Let's think about this problem. We're converting into moles. Make sure we do that step right. All right, we're converting into moles. There we're converting into moles. All right. Then we're using that with the ideal gas law to calculate the partial pressures, or the pressures of each individual each individual gas. Then we're adding those two pressures together using Dalton's law to get the total pressure. And we did it. All right. So again, make sure things make sense with your answers. I was getting a very small pressure, and that didn't make sense. So I went back and checked my work, and lo and behold, I made it right. So you should have got 2.47 atmospheres for the pressure of nitrogen. Then you should have got 0.978 atmospheres for the pressure of chlorine gas. You add them together, you get 3.5 atmospheres for the total pressure. Okay, guys, good work. Looking forward to tomorrow. This is Coach Scott with Red Devil Chemistry. Peace out.